A bold revelation about one of the cosmos' most elusive mysteries is finally in. A long, targeted look at a supermassive black hole's jet has pinpointed where its X-rays come from, resolving a question that has lingered since the dawn of X-ray astronomy. This new interpretation appears in the astrophysical journal Letters, as reported by the American Astronomical Society on November 11, and it stems from an international collaboration using NASA's Imaging X-ray Polarimetry Explorer, IXPE. IXPE's marathon observation focused on the Perseus Cluster, the brightest galaxy cluster seen in X-rays. Over a 60-day span, from January through March, astronomers logged more than 600 hours on this single target. Not only is this IXPE's longest single-target campaign to date, it marks the mission's first deep dive into a galaxy cluster. The primary focus was 3C84, the giant active galaxy at the heart of the Perseus Cluster. 3C84 is a prolific X-ray emitter and a staple target for X-ray astronomers thanks to its relative closeness and brightness. Because the Perseus Cluster contains an enormous reservoir of hot X-ray emitting gas, hot enough to rival the Sun's core, scientists needed the sharp view provided by multiple X-ray observatories. The team combined IXPE data with high-resolution imagery from NASA's Chandra X-ray Observatory and integrated measurements from NuSTAR and the Neil Gehrels Swift Observatory to separate signals and build a clearer picture. Some key points driving the interpretation. IXPE's polarization measurements reveal the orientation and coherence of the emitted X-ray light waves. A higher degree of polarization indicates greater alignment among the waves. Inactive galaxies like 3C84 are believed to produce X-rays via inverse Compton scattering, a process where photons gain energy by colliding with energetic particles. IXPE's polarization data helps distinguish this mechanism from other possibilities. Seed photons refer to the lower energy photons that are boosted to higher energies during inverse Compton scattering. The Perseus Cluster is also familiar to many readers through its association with an audibly rendered sonic representation of a black hole. Researchers released a sonification of Perseus in May 2022. According to Stephen Ehrlich, IXPE project scientist and a NASA Marshall Space Flight Center astronomer, the long polarization measurements of 3C84 were a central objective, but the team remains open to uncovering additional polarization signals within the cluster that could point to more exotic physics. Ioannis Liadakis of Forth, Greece, and lead author of the study, explains that the IXPE observations have decisively shown that the X-rays from 3C84 originate through inverse Compton scattering and have provided a unique opportunity to characterize the seed photons involved. Two competing origin scenarios for those seed photons were considered. Synchrotron self-Compton, SSC, where the lower energy photons come from the same jet that accelerates the high-energy particles. External Compton, EC, where seed photons arise from background radiation sources outside the jet. Friedrich Murren of the Strasbourg Astronomical Observatory notes that SSC and EC make distinct predictions for X-ray polarization. A positive detection of X-ray polarization from 3C84 essentially rules out EC as the emission mechanism. To strengthen the test, researchers coordinated optical and radio observations from facilities around the world throughout the 60-day window, aiming to differentiate the two scenarios. The analysis yielded a net X-ray polarization of about 4% in 3C84's spectrum, with similar polarization levels observed in optical and radio data. This trifecta of measurements strongly supports the SSC model, indicating that seed photons originate in the same jet that accelerates the energetic particles. As Sudip Chakraborty from the University Space Research Association emphasizes, separating these components was crucial and was achieved through the synergistic use of IXPE polarization data with data from Chandra, NuSTAR, and Swift, allowing a polarization signal confidently tied to 3C84 to emerge. The team will continue mining IXPE's data from different regions of the Perseus cluster to search for other polarization signatures that might reveal new physics. IXPE remains a joint mission of NASA and the Italian Space Agency, with collaborators in 12 countries. Led by NASA's Marshall Space Flight Center in Huntsville, Alabama, The mission's spacecraft operations are managed by BAE Systems Incorporated, in collaboration with the University of Colorado's Laboratory for Atmospheric and Space Physics in Boulder. Learn more about IXPE's ongoing mission at https://www.nasa.gov/IXPE